So far, we have seen the big picture of the network. In this presentation, we will dive into one school professional learning community to explore how the participants develop their own breadth of inquiry for 4 years with Studio model. Studio is a key professional development model in our network that was designed to promote teachers' collective inquiry on ambitious and equitable instructional practices in their own school settings. So in a studio, a team of science teachers, instructional coaches, researchers, and sometimes administrators gather for a full school day. One of the teachers becomes the host teacher for the day. All of the participants first co-plan a lesson that features some ambitious and equitable practices. Then they all go into the host teacher's classroom to co-teach the lesson. And they reflect on the lesson using multiple forms of student learning data that were gathered in the class. Then they revise the lesson and do the second round of teaching and reflecting to conduct principled experimentation and generate practice-based knowledge about what works for whom, under what conditions. By having studios 2 to 5 times a year, teachers engage in multiple cycles of inquiry to test and improve their instructional practices by closely interacting with their own students. This study focused on how a team of high school science teachers develop cycles of inquiry in studios for 4 years. Especially, the team focused on improving their modeling-based teaching, which is one of the ambitious and equitable science teaching practices. Modeling-based teaching engages students in knowledge-building processes of science by inviting them to construct and justify their own scientific explanations and models using evidence. Then we explored how the teachers' interactions in the professional learning community, PLC, guided and got shaped by their pedagogical frames about scientific modeling, which are teachers' understandings and expectations about scientific modeling and modeling-based teaching. The participants of this study are members of a high school science PLC in the network. The PLC included 5 to 6 science teachers and university and district partners, and they had 10 studios during 4 years. The data includes video recordings, field notes, artifacts from the 10 studios. We also conducted interviews with 2 teachers who were the only teachers that stayed in the community for the entire 4 years after the 10 studios. We qualitatively analyzed the data to explore the patterns and characteristics of the team's inquiry over the 4 years. Practice, data, and theory. These are the 3 components of the learning loop for improvement work that the improvement scientists have suggested. In studios, teachers conduct inquiries on instructional practices by collecting and examining student learning data, and build local or general theories of student learning or teaching to improve their teaching. So in this study, we use this learning loop to explore how the team's inquiry evolved. Especially for the theory component, we focused on how the teachers' pedagogical frames about scientific modeling co-evolved with their work on practice with data. So here are our findings. In early studios, especially during year 1, the teacher's inquiry mostly focused on tweaking and testing pedagogical tools, especially scaffolds on the model templates, which are worksheets to help students' creation and expression of models. In these days, the tools and interactions around the tools not only mediated students' learning in classrooms, but also mediated teachers' sense-making about what is scientific modeling. So here's an example. In Studio 2, students constructed models about cellular respiration and photosynthesis. And in the planning period of the studio, researchers and coaches introduced a model scaffold named activity summary table, which can help students use their learning from different unit activities as resources in constructing their own models and explanations. However, this model scaffold made teachers recognize modeling as an activity to put already learned knowledge pieces together rather than an epistemic practice. This frame was revealed from the teachers throughout the day. For example, when the host teacher introduced modeling to her students, she said, models are examples of how things come together. And when examining student work, they focused on whether the students included scientifically correct ideas in their models and what science ideas that they were missing or misunderstanding. But as the inquiry moved on, the teachers focused on different model scaffolds, such as guiding questions to help students construct explanations about puzzling phenomena. For example, why does Seattle get so much rain? And student-generated explanation checklists, rubrics, and other scaffolds to support students' causal explanations. Through working on these model scaffolds, by the end of year 1, the teachers came to understand modeling as a knowledge-building practice to construct the explanations of phenomena using evidence. Furthermore, through working on cycles of inquiry to improve their modeling-based teaching, the teachers started to expand their pedagogical frames about scientific modeling based on what they see from their own students' engagement in modeling. For example, in Studio 6, a teacher, Emma, said, the level of thought processes that they were using was above and beyond what I felt my students could do. They prompted others thinking, like they asked, can you explain me more about that? Can you clarify that idea? So this means those teachers were recognizing that students can collaborate and learn from one another through modeling. She went on to say, and I think the model is like the multiple entry points where students can write down their thinking. It really allows them to start where they are at. So here, the teachers were expanding their views about how scientific modeling can support their students' learning based on what they see from their own students. With these aspects of pedagogical frames, the team's inquiry focus moved on developing and testing instructional practices to support all students' meaningful participation in modeling, knowledge-building processes of modeling. Through promoting classroom discourse, supporting diverse students such as English learners, and building classroom community to help students learn from one another, for example, by developing peer feedback rubrics or structured talk protocols. So here's our discussion. Like this PLCs in the network develop their own threads of inquiry and collective expertise, including the pedagogical frames through testing practices and examining student data in studios. Tools and diverse rules in the network facilitated the teachers' collective inquiry and learning. These findings led us to ask this question: how do the school communities share and benefit from resources, practices, and expertise across the network? This question will be addressed in the upcoming presentations. Thank you.